Hello everyone, welcome to my YouTube channel. My name is Ernie. In today's video actually is a continuation of my previous video about monitoring PM2.5. In those earlier videos, I show you how to analyze air pollution using dataset from MERA and the GEOS-CF here. If you haven't watched them yet, I recommend it checking it out. Those video first for better context. And now in today's video, we will go further by exploring another powerful data set, the Goddard Earth Observing System Compositions forecast, or we can call it GEOS-CF. I will show you how we can use these data sets in Google engines and to monitor PM2.5 more effectively. So first you should sign in this platform, and after you sign in, you can go to the code editor to write your code there. So just go to find about the geos if you want to know about this data set. So what is GEOS-CF? GEOS-CF is a high resolution global atmospheric prediction system by NASA, and this dataset merges meteorological atmospheric chemistry data and integrates the chemistry model. And in this GeoSAP, we can access for data for 5-day forecast for the pollutant air, including the ozones and carbon monoxide and the nitrogen dioxide and the sulfur dioxide and yes, of course, about the PM2.5 that we will try to analyze today. But if you want to monitor another parameters like ozones or CO or NO2 or SO2, you can use these data sets. And this dataset is the spatial resolution is around 27 kilometers, and making it suitable for the regional or to global analysis. So today we will use the band. This one, if you want to know about the band name, there is so many band here you can use for the monitoring. Today we will use these band names as our data set here. PM2 25 RH35 GCCC. RH35 means is the relative humidity is around 35%. And that's about the little overview about these data sets. But first, for the this step is you should define your ROI. Here we will use the data from the FAO. So today I will use this data sets FAO level 0 for country boundary. If you want to make it more detailed, you can use level 1 or level 2. Level 1 for from province boundary and level 2 for the district boundary. So here I will use this band name and keep the string with my country name, Indonesia. So but first we should put one geometry here, Actually, this geometry or this point you can change as your locations, stations monitorings. For example, I will try. If you didn't have, you can put in the city that you want to do the monitoring. For example, here is Jakarta, but it will be better if you have the ground data. So you can compare the data set from the satellite and the monitoring stations and get the relationship between the data from the satellite and the monitoring stations. So from that correlations or the from the relationship, you can get the data using the satellites from the place that maybe there is no stations for monitoring. That so first we should put our geometry and filter bounds, yes, with our geometry with the FRO level 0 here, and this one is for add to our window and make it as a center object, and just run it, and after a few moment it will be showing your ROI on your window. Here is by country Indonesia, and after that you can yes, go here to make variable collection, for example, for your data sets. So you just copy this snippet first and do the select your, for example, your band name here, because we want to do the monitor PM2.5. We will use this band name. Just copy here, and after that you can filter bounds with your ROI name and filter date with your dates. Today I will show you only for 1 month. You can get the data actually from 2018 here until now. So you can change it by yourself. But today I will show you only for 1 month, August 1st until 2025, for example, August 31st, and just run it. Okay, so here I have already make a functions for this data set. Actually, I have already to make it more, yes, simple here. So I have already make functions for this data collections to clip with my country here, and this one is, and I will keep the properties with the property CSA time start, and this one is for add to the layer and get the mean value for this 1 month, and give the name is PM2.5 here, and just run it. And here is, I want to know how many data set that I have in this area. So I have 722 images here. And okay, now is this one is for the chart. If you want to make a chart, time series chart, you can use this code. Just make a ui.chart.image series here, and image collections you can get for from this variable PM2.5, and a region you can choose because I want to check the points that I have already put here. So the region I change with the geometry, and this one is for the statistical that I use is mean value, and the scale is 27 kilometers, and the x properties it will be time start, and this one is the set the series name here is PM2.5, and the x-axis here is PM2.5 in microgram per meter cubic. And yes, that's about this code. And this one is for the lines width, and the point size. This point size is 2. You can change it by yourself. That's about this code. And after that, after you run it, you will get this your chart in this console menu. And if you want to download this chart, you can click it in the chart here. Okay, need a little time. Okay, now it's already showing. You can download in CSV format, or you can download this image with the PNG format. So as you need, you can change it. And after that, okay, if you want to make this map more informative, you can go to here to set your visualizations. For example, make a strike on 90% and give the palette here. So for example, yes, from this, and the last, for example, we will give here. Okay. So if we do the strike this image with the 90%, you will get the value is from 8 microgram per meter cubic until 62.1 microgram per meter cubic. So just apply it to have the visualizations. So here you can see that this area is the highest, PM2.5. Again, need a little time for the visualizations. And if you want to make this visualization as your permanent, you just import it and copy this visualization and change with your visualization here. Just run it. Now it's already showing for us. That's from my side today. I hope you can use these data sets. Yeah, different data sets. You can compare it, or you can, and you will get one value maybe in your area. It will be this one is will be suitable. Then another data set that I have already show you on my previous video. Thank you very much for your attentions, and I hope yes, see you in the next video. And if you have a comment, you can write in the comment. Thank you.